Okay, so we talked about bond polarity. Remember we talked about, let's say HF, right? This is more electronegative, so, you know, I'm going to have a dipole moment, right? It's going to be more electrons around the fluorine than there are around the hydrogen. But we can also talk about dipoles within a molecule. So, whoops. So I can have a molecule where I have polar bonds. In this case, carbon and oxygen are polar, right? Oxygen is more polar than carbon, so the dipole goes this way. And I've got the same thing on the other side, the dipole going the opposite way. And the overall dipole for the molecule is 0, and that's because if you add these two vectors together, they cancel each other out. So even though I can have bonds that are polar in a molecule, I can have an overall nonpolar molecule. So this is what CO2 would look like. It's nonpolar. There's no part of this that's sticking out that's going to be more electronegative, that's going to cause it to be attracted to itself. So I can actually show the bond dipoles and then show what happens for the overall. So here I have water. The hydrogen is less electronegative than the oxygen, so my dipole for the bond goes this way. If I add these overall dipoles together, I have a dipole that has the top of the molecule being more electronegative than the bottom, right? So I can show an overall dipole for the molecule. So here I have a molecule. It's only got one bond, and that bond is polar, has a dipole, so the molecule is also polar. Here I have carbon tetrachloride. Each of these bonds is polar, and the dipoles show facing the chlorine because they're more electronegative. But if I add all of these dipoles together, they cancel out. It becomes nonpolar. Here I also have polar bonds, in this case with the nitrogen being the most electronegative. But this is a polar molecule because if I add these dipoles together, the dipole faces that direction. Here I have a symmetrical shape. I have dipoles on each of the three bonded atoms. They're all facing the same direction. If I add these three vectors together, I'm going to get 0. So this becomes nonpolar. I can take the same nonpolar molecule here and I can change one of the atoms, and now I have a polar molecule because this is the chlorine is more electronegative than the hydrogen, so these are smaller. These are smaller, right? And this becomes polar. So if I have a symmetrical molecule, everything's the same on the outside, no lone pairs. I have a nonpolar molecule. It doesn't matter what's on the outside. If I have one thing that's different on the outside, it's going to become polar. If I have lone pairs, I will always be polar because those lone pairs are going to stick up and they're going to be negative. It's going to cause a dipole.